The majority of the things we use in our day-to-day lives undergo more complex processes than just acquiring it. To some, this would mean going under high temperatures, molding, and a lot of cutting. In this Mighty Machines video, let's take a look at these complex yet amazing industrial processes day-to-day products go through. Don't forget to like and subscribe as you watch this video. First on the list of processes you shouldn't miss is the assembly of the WinGD 12x92DF. In this video, you can see how hard the engineers are working just to assemble this unit. To give you an idea of how huge this is, it's reportedly bigger than any average house and weighs about 2,100 tons. This is also known to be the biggest two-stroke dual-fuel engine, designed for modern large and ultra-large container vessels. Aside from its size and weight, this engine also has other charms. With its low-pressure dual-fuel technology, it can now address the market requirements of providing a propulsion solution capable of running efficiently, effectively, and safely on gas, on top of conventional heavy fuel oil or diesel oil. It's also very impressive how at just 80 RPM a large cargo vessel can already draw 85,610 horsepower from it. All these perks while being eco-friendly, as it also meets their Tier 3 emission requirements. Industrial processes also include the removal of burnt carbon from glass molds. Usually it's done with the help of various chemicals and ultrasonic solutions, but to do it faster, laser technology is used. Through this, a huge amount of burnt carbon is cleared, even when the shortest possible of time. One of the innovations used for this is the P-Laser high-power system in 2000 watts. This laser technology combines high pulse power with large surface coverage and is controlled by a 19-inch control unit. It's available in 3 configurations: 500 watt, a 1000 watt, or a 2000 watt laser source. This 2000 watt version doubles the energy of a 1000 watt system and speeds up the process more. The machine optic can also be integrated in any production or assembly line, since it's a robust and durable unit, but flexible enough to be installed on a robot. If the optical components get too heated during the operations, its water cooling system will regulate it, as well as the integrated air treatment to cool down the optic and avoid dust onto the lens. Up next is this innovation by Pestan. These corrugated pipes have 2 layers which act as a smooth inner wall and external spiral wall, which are made up of high-density polyethylene. If you're wondering how it's made, this video's for you. First of all, a corrugated profiled outer layer of high-density polyethylene is winded on a smooth inner layer. To do that, this layer must be extruded and welded. The addition of profiled hose in the outer layer is proven to increase and improve pipe strength and can be manufactured in a variety of stiffness classes. A lot of things we use today, like utensils, buildings, and even some car components, are made up of iron. Iron is ideal for all these things since it has higher strength than other possible elements, and it also is the most abundant in the Earth's crust. However, the process of integrating iron into materials goes beyond just acquiring it. The ANYANG forging press, you can see how a simple iron can turn into something more useful. Through the help of a variety of molding methods, they're able to continue their production. They have a machine that helps them shape the metallic unit into a round shape through the process they call the ring rolling technique. This technique is usually used for seamless machining, bearing rings, hub flanges, thin wall cylinders, and many other components. To guarantee that they remain in the desired shape, a glass room operator monitors the process. As the time goes by, the mattresses we use often get old and their shape doesn't stay good anymore. As a solution, people get newer ones and throw away the old mattress. But did you know that the RETOURMATRAS can recycle up to 90% of that mattress? Once the mattress is delivered to the recycling facility, it will go on a recycle journey along with the hundreds of other mattresses delivered to them every single day. The process starts with them detecting and removing the metal within the mattress. After that, the covers will be removed so that the remaining foam can be cut into blocks. This is done so that it's easier for them to do the next step, which is the shredding of these foam blocks into smaller pieces. Then the process of chemical recycling, or the separation of polyethylene from the foam from its original chemical raw materials, begins. In this part, they use a special chemical recycling technology known as glycolysis to obtain polyol, which is then used to make most new foams. The gears whose axes of the two shafts intersect and the tooth-bearing faces of the gears themselves are conically shaped are called bevel gears. Most of the time, they're mounted on shafts that are 90 degrees apart, but can be designed to work at other angles as well. You usually see bevel gears on items like devices and machines, including automobiles, printing presses, power plants, cooling towers, marine applications, steel plants, and railway track inspection machines. But how do they exactly make it? Usually, there are two manufacturing methods used for bevel gears. Depending on what is used, the tooth length and depth forms may vary. In this clip, you'll see another way of manufacturing it, which is the computer numerical control, CNC. First, a machine that produces large spiral bevel gears is used. Once its task is done, the CNC takes over and proceeds with all the grinding and turning operations. Then the bevel gears are now used for specific items. For example, the Glendenberg's C300, which is one of the world's largest machines. Whenever looking through clothes, many prefer cotton since they're comfortable, but did you know that cotton is also the most common natural fiber in the world? This is why there are also the ones you use to make yarn. In this clip, you'll see that a lot of new cotton is being delivered to this yarn factory. The machines will now take over these and clean them. Once it's set, the cotton fibers are separated in the catering process before assembling those into a loose strand known as slivers or toes. After that, the slivers are transferred into the drawing machine where slivers are aligned and stretched. The product of this step is further reduced so that a finer thread is achieved. Strength is important for yarns, so more twists are added to these threads before winding it on a smaller tube. The roving machine then spins and twists the yarn up until it becomes 60 times thinner than how it originally is. Approximately, this whole process takes only 48 hours of machine work. We've already come to the last item on the list. That's all for the complex yet amazing industrial processes day-to-day products go through. Did you enjoy watching? If so, please don't forget to leave a like, subscribe, and click the notification bell. We'd also be glad to hear your thoughts and suggestions in the comments below. Till next time, thank you for watching.